Hey everybody, I'm Jim. Welcome back to the 312 Workshop. Today we're going to dive into the world of 3D printing and how it can both improve and streamline the workflow in your shop. Whether you're a beginner or a seasoned pro, we'll cover what works, what things you should avoid, and the best settings to make your 3D prints both strong and functional. Let's get started. Okay, first up, let's tackle the big question. Should you buy a 3D printer for the workshop? I mean, the technology has changed drastically in the past several years, and it's almost a plug and play situation. And let's face it, it can improve productivity and creativity. However, with any tool, there are pros and cons. So let's talk about those next. Okay, first pro is precision and customization. You can basically print what you want when you want, and you can alter some things if you want. There's a plethora of things out there that can be printed. In this case, I wanted a 3/4 inch setup block. Not bad. You do have to take into account that it is accurate to a point. I have a set of calipers here. And as you can see, I am 2/1000ths of an inch off. Now, for woodworking, that is totally fine. Would I use it in a machine shop? No. But the thing is, I only wanted a 3/4 inch setup block. So I found a bunch of files that were all different sizes and just picked the one I wanted and print it. Now, as time goes on, and I may say I want others, I need a 1/2 inch block, I need a 3/8 inch block, I can just go print them. They will be marginally off, but 2/1000ths of an inch in a workshop, in a woodworking shop, is great. Pro 2 is cheaper prototyping. Now, I printed this first, and you're going to say, okay, what is that? And then I printed this one next. It's a 30-degree angle that I can use on my table saw slide. Whoops. Because I don't have a very accurate miter gauge. I haven't added one to my saw yet, and I know there's some out there. But time of year, it's a little after Christmas, and they're all sold out. So I was able to prototype this one, mock it up in the 3D design software that I use, Tinkercad, and then I was able to alter it so that it would print faster. Seriously, I think I have about $1.20 in filament between both of these prints. Pro 3 for having a 3D printer is organization and streamlining the workflow a little bit. As you can see, I've got a lot of chargers, and I've also got a lot of drills, drivers, and heat gun tool, hot glue gun. You see, I printed little hangers, and I could have made them out of wood. I understand. I could have made them out of plywood. So instead of having all this stuff around, and like all here are my chargers, instead of having them laying on the workbench, they're now up. And then, of course, you can find battery clips. And I was able to print a bunch for the different types of batteries that I use. Some of the chargers do have screw mounts. I can mount them directly in, but these quarter cable ones, I found this file on Tinkercad, and it was real easy to print. But that, to me, is what makes this more of a tool instead of printing little tchotchkes. You can still do that. That's fine. But to be able to print things, to organize this space better so that I'm not laying things on the workbench, really helps my workflow in this small shop. Now we're going to talk about the cons, why this is kind of difficult. And one of them is the initial expense. The initial expense can be kind of high. I happen to have bought a Bamboo Lab P1S. I upgraded to a P1P. I got the parts and put on it so that I could print in an enclosed space. And, you know, I've sunk $550, $600 into it. And that's just the printer. That doesn't include the filament, which, you know, that does add up over time. Granted, printing the filament is, you know, pennies when you're talking about some of the things I've printed here. But also, too, there's a learning curve. Any 3D printer needs what's called a slicer. It's a way of generating the code that a printer can work with so that it can, lay down those lines of filament. It's interesting because I think of 3D printing as printing with a hot glue gun. You lay a bead, and then you lay another bead, and then you lay another bead, almost like building up beads when you're welding. Not that that's a great practice, but it's done sometimes. Also, too, you do have to factor in maintenance and reliability. Now, reliability, a lot of the printers that are out there now, the Bamboo Lab one, the Creality, the K2, I think it is, even the Prusa, what is it, the one, it's the boxy one. Some of the companies have really stepped up and really made printers pretty reliable for the most part. Now, there is some maintenance you do have to do. You do have to make sure that you're not getting dust in them, or in my case, cat hair. That's another reason I went to the enclosed printer, to make it a little easier, keep the dust out. And that's also part of the reason why my 3D printer is not down here in the shop. You should keep it out of the shop proper, because a wood shop's a dusty environment, and dust kills. That's just the way that works. Now, let's discuss what to print. Now, you've got two options. You've got pre-made files called STLs, pre-made STLs, or, as I discussed before, you can go and design your own things in 3D software and then export them as an STL file. Now, some of my favorite sites to get files from, Thingiverse, MakerWorld, Printables, Cults 3D, and there are dozens of sites out there, and some of these sites have thousands upon tens of thousands of prints, storage solutions and templates, jigs, and things like that. I mean, you can find pocket hole jigs on Thingiverse and use them, and they'll get you a couple pocket holes. If you need 24 pocket holes, well, it's a lot easier if you have a 3D printer to grab a free file and use 80 cents worth of filament, maybe $1, print the old style Craig 2-hole pocket hole jig, and then use that for the dozen pocket holes you need. Now, the other way to do it is like I showed you, designing your own. Now, I happen to really like Tinkercad. It's basic, but it so far gets me to where I'm going. It gets things I can design quickly. I think it kind of reminds me of the old Microsoft Paint, which is weird because I'm an Apple guy, always have been. But Tinkercad is a good introduction. Okay. Now, if you want to step it up a little bit, there's Blender. There's what's some of the other ones there. FreeCAD is another one online. Fusion 360 is probably the better one out there, and it gives you the most control over all the parameters of what you're designing. There's a pretty steep learning curve, and you're talking to somebody. This is somebody here who, granted, it was 35 years ago, I got a 2-year drafting and design degree from a community college. And our last set of classes, we were working with AutoCAD. And I think AutoCAD was only on its second version, I think. Anyway, but that gives you a good option. Start with Tinkercad and then work your way into Fusion 360. Or just print what other people have designed. Now, granted, I bought my 3D printer to print little things and get my daughter interested in designing 3D printing. She does have a kind of an artistic bent, and so far she's been kind of interested in what's going on. At some point, she wants to sit down with me and really go through Tinkercad of how to design something. But really, what should you print? Well, there's tons of things to print that are already made. I've got a little glue caddy, so I don't have to Not that I have a huge shop, but not that I don't have to walk back and forth. We've got that. Um, yes, I did. I did start with the little tiny tchotchke, as it were. My mom wanted a little heart box for her jewelry and whatnot. One thing that's very useful are these. Believe it or not, this is a phone charging cable. This is a cable reel. This is like a 6-foot cable that I can just wind up in this thing, and they are really handy. I bet I've printed 4 dozen of these things and given several away. Also, too, like you saw, setup blocks. It works. I even went as far as to print a 1, 2, 3 block. It's mostly accurate. Again, we're off a couple thousandths, but it's not terrible, and it could be used. It doesn't have the weight, unfortunately. Other things you can print, things for dust collection. Holy crap, things for dust collection are awesome. Now, I found these. I think I found this on Printables, and I don't have it screwed together. But this is basically a ball valve for your dust collection. Because let's face it, the plastic 2.5-inch gates, unless you mount them vertical, if you mount them horizontal, they get dust in them, and after a while, they won't close. So I'm switching to those because that to me just makes the most sense. I've even got little things that I can mount them, and I'm going to just go ahead and move this now because this will be easier. So yeah, I've got a ball valve here, and then I've got a dust attachment to it, kind of like lock line, if you can think of it that way. But this works as dust collection for my drill press, which is really, really handy. Now, other things you can print. Light duty clamps. Now, I wouldn't go nuts with this, and this is actually a sequence of files. Again, I think I found these on Printables. And this is there's one smaller than this, and then there are 3 that are larger. There's one that's, I think the jaw opening is 8 inches. I don't know why I would print that, but for little things, I got to clamp 2 small pieces of wood together. These work. And whoever designed this in such a way that you don't need a ton of support material because you have overhangs. But yeah, really handy. Another thing too, believe it or not, and I was kind of iffy on this, spring clamps. There's about $1.60 in filament, and I got creative and printed in 2 different colors. But these work pretty decent. And if, again, I wouldn't use these to try to glue pieces together and take a bow out of a piece of wood. But for light duty stuff, these are really handy. Another thing I printed, which is kind of interesting. Yes, I am cheap, and I go to Dollar Tree to buy my little tubes of CA glue because you can buy 2 for $1.25. A little more expensive on Amazon. But anyway, I printed this little holder that allows me to squeeze. These work pretty good. Again, somebody made this. I might try to design something that's a little different, maybe a little more robust. Another thing that I printed, center finder. Center finder came from the same guy who designed that lock line dust collection thing. Anyway, I'll try to remember to put these links or some of these links down in the description so you kind of can get a handle. But again, you just go to Thingiverse, Printables, Cults, Maker World. You can find these things. And then we've got this, featherboards. I'm a little iffy on these. And the only reason I'm a little iffy on these, I found 2 or 3 of these little inline for the miter slot of a Delta 735, but they didn't fit, so I had to kind of redesign my own. I'm a little iffy on these, and I'll explain that here in just a second. Because I printed this. This is a zero clearance insert for my table saw. And now we're kind of getting into the realms of things to avoid, things you should not print. As you can kind of see, it chipped out a little bit. I had to cut it very deeply for the riving knife. And it's too light. So I've printed it. I'm not real thrilled with it. I'm just going to go ahead because making them for the Delta saw, the 735 is a little hard because you've got to cut out a lot of things. And honestly, as far as my time goes, I'll just buy some wooden ones off Amazon or Etsy or something like that. But yeah, there are some things you should not print. Push sticks. Matt Outlaw over at 731 Woodworks, he did a video where he talked about plastic push sticks hitting the blade and can they shatter. Well, I didn't video it, but I will tell you, a printed push stick, if it hits the blade, and it may have been just the angle I hit the blade at, pretty much explodes. There was plastic shrapnel flying everywhere. Thank goodness I always wear these safety glasses. Anyway, now, another reason to get into Fusion 360 if you can are these. This is what's called a parametric box. Now, I actually use this in my office for storing flash drives. But this file, it comes as a basic STL. I think one of them. I've got several of these. They're called parametric boxes. So you can load the file into Fusion 360, and then you can alter the parameters to make the box bigger or smaller. I made this significantly smaller than it should have been, or that it came, because I wanted something that would just do flash drives. Now, this is a different file, but it's also a parametric box. So they are very handy. And because sometimes you just can't get the small size box you're looking for. And my phone has just gone off. So to sum up, you should focus on things for dust collection, light duty tools, light duty clamps, things like that. Storage solutions. You saw what I did over here with my cordless tools. Really makes things handy. I have a storage wall for drywall screws and nails and things like that. And I purchased it. But I purchased it before I had the 3D printer. And if I'd have known, because you can print those storage boxes, the files are out there. One other thing that I printed that is awesome, and this is starting to open up a whole new concept of what a 3D printer can do. I have a roughly 40-year-old corner cabinet, and it's got glass in the doors, and the clips that hold the glass in are starting to break because they're plastic and they're old. It's just the way it is. I went and priced them on Amazon, and the cheapest I could get them down was 11 cents a piece. I printed these for 2 cents a piece. And I didn't have to wait for them. I mean, seriously, I was like, oh, this one broke. I've got to get this fixed. I've got to get these things ordered. And I went in and fired up the computer and started looking at Amazon. And I went, wait a minute, I have a printer. Somebody has to have the files. Damned if I didn't find the files on Thingiverse. Like I said, I printed 22 of them for 2 cents a piece. And I didn't have to wait for shipping. You can't beat that. And that's opened up even more concepts of what I can do. 3D printing really is starting to get into that realm of where it's yes, there's still hobbyists and tinkerers out there who want to trick out their printer, their Ender or whatever, and they want to print the fastest Benchy. Benchy is a little boat that's used as kind of a benchmark for how your printer is performing. Yeah, there are people out there printing benchies in like 80 seconds or faster, believe it or not. They look like crap too. But you know, there's always going to be those tinkerers, and that's fine. That's where this has got us. Those tinkerers got the hobby to where it's almost not a hobby anymore. It's not quite Star Trek Replicator, but the fact that I didn't have to order clips to hold glass in at 11, 12 cents, whatever it was, and I could print them for 2 cents a piece. And I'm like, ooh, what else can I print? So that really makes sense. Now, types of filaments, and we won't get too much into this. We're just going to keep with the basics. Everything printed here is printed with the ubiquitous beginner filament, PLA, polylactic acid. Okay? I think that's how it's pronounced. Anyway, don't shoot me. But everything here is printed with PLA. The only downside to PLA is it doesn't like heat. If I took one of these cable reels and left it in my truck in the summer, like in a parking lot with sun, it would start to soften up. It would melt. That's why I'm not 100% sure on this radius jig for a router, you know, to put a 3/4 inch radius on a corner of a table, because the bearing doesn't spin, but the cutting action of the wood generates heat. And I'm not sure if that heat will start to deform this. That could be a problem. But that's, you know, that's one thing. And if you want to step it up, you can do PETG, or PETG as they call it. PETG has a little more resilience when it comes to heat. Structurally, it's, I don't know, fractionally stronger, maybe. I've seen different things on YouTube, different people testing different things with, like, you know, force meters and impact and all that. I will say, the plastic, the PLA especially, does not like plastic. That's why my general thought to you guys is keep PLA away from spinning blades, spinning router bits. I think that's a good, safe way to go about it. I think PETG, boo, would react the same, and I think you do PETG for a little more heat resistance. Now, another filament is TPU. TPU is very similar. I have an OtterBox on my iPhone, my other iPhone, my iPhone. I have an OtterBox on it. You see the soft covering on the OtterBox? That's kind of what TPU is, and I'm going to start experimenting with that. I actually have recently found a file for a certain company's featherboard with those funny soft rubber inserts. And I want to try that, print it in TPU and see what it does. But again, the plastic hitting a spinning blade I think could be an issue. That's why I'm not sure about these, because you can lock them down. And I realized I put the things on backwards. You can lock them down and then run your board through. But if it starts to creep, could it twist and hit the blade? That could be a problem. Now let's talk about filament blends. I won't get too far into this because I want to be able to print things without worrying about volatile chemicals, you know, smells, etc., etc. But you can do glass reinforced nylon. You can do carbon fiber reinforced PLA. There's ABS is another one that evidently is very strong, but you have to be able to vent outside, and that's not where my printer is right now. So I'm just going to stick with PLA, maybe a little PETG, which, by the way, PETG, you can smell, it smells different than when PLA is cooking, as it were, as it's heating up and running the lines. PETG has a little more of a chemical smell. So that's probably as far as I'll go down the road. And yes, there are people who are printing pew-pews, with carbon reinforced nylon and glass reinforced nylon, those kinds of things. And that's fine. And that may be where I end up going eventually. But for right now, the things I'm using in the shop, PLA, maybe a little PETG, maybe a little TPU will be fine. Okay, so I've got this loaded up on my computer. This is the slicing software for the Bamboo printer. Let me see if I can get you a little bit closer. Whee! Everybody have fun. Okay, and I'll do a little bit of lift. There we go. I just realized the way I'm shooting this, I'm gonna have to flip everything in the editing software. Anyway, you can see I've got a 1, 2, 3 block up here, just as an example. Over on this side are your settings. And what I mean by settings, you've got wall loop, how many perimeter loops it gives you. Top shell, the top is here, the way this will print, and then I'll flip it over, and this is your bottom. See, I'm looking up through the bottom of it, as it were. So you've got top, you've got bottom, and then you've got your loops. For non-structural things, i.e. the glue caddy, okay, or the little dust collection ball valves that I've built and printed. Seriously, this thing defaults to 2 wall loops, and I think it does 5 top shell layers and 3 bottom layers. For something like that, I would just do 2 wall loops, 2 top shell layers, and 2 bottom shell layers, or maybe 3. That can help you. So we're going to go ahead, and I'm going to say, okay, we're going to give it 3 all around, right? Now, you've also got infill. Infill is between the walls, between the loops and all that. Bamboo's really good at printing gyroid. They're all different types. There's triangles, trihexagons, honeycombs, 3D honeycombs. I tend to stick with gyroid. It tends to be the fastest. It is set right now. I'm going to set it for 15% infill, and I'm going to tell it to slice. Yeah, I don't need the daily tip. Go away, daily tip. There we are. See, and it gives you, and it tells you what's what. We'll shrink that. We'll make this bigger. And now we will, and you can do this with a slicer, which is really cool. You can see how it's printing. See, the red area here is your infill, and you see there are 3. I'll zoom into the walls here. See, there are 3 walls. For most of what you're doing, 3 top layers, 3 bottom layers, 3 perimeter walls, 15% infill on gyroid is totally fine. You know, it's a setup block. I could even scale everything down to 2 and maybe go 10% gyroid, which would lighten it up. Here I'll go ahead and do that. Give you an example. 2 bottom, 2 top, 2 walls. We'll slice it again. We'll get rid of this. And see, now there's less infill and there's only 2 walls. And see, we can like, it's like we're going down through the item. All right. I honestly believe for most things in the shop, dust collection, setup blocks, even the boxes, 2, 2, 2, and a 10% infill is fine. Now we're going to move it. You got an idea what the slicer can do, and I am way too high again, so we're going to have to move this. Lock, 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 down, and tip. There we go. That'll give you a good idea. All right. So, like I said, for dust collection, I think I actually did 3 walls on these just for the basics. Okay. The support structure was 3 walls with 20% infill because it's going to hang off of them. Feather boards. I stayed with 2 walls with a 15% infill to give the fingers a little flexibility. I did not do that on this one. I did 3 walls. And what ended up happening was the fingers are so narrow, the 3 walls came together. And instead of doing any kind of infill pattern, it just printed. So these are actually solid. And they're somewhat flexible, not as much as I'd like. I designed this. I know, you're looking at it going, what? I made the walls a little too thick. But, you know, I stayed with the 3 walls. There's no infill in this. I stayed 3 walls here. There's a little bit of infill here. Joined them together. I designed this in Tinkercad. I have a buck tool sander. Has a disc on one end and a belt on the other. It has 2 outfeeds for dust collection. One goes to one goes to the other. I put a ball valve on top. Boom, I got dust collection to my sander. This one, I actually printed this with 2 walls, 15% infill, basically almost the stock settings. The only thing I changed was instead of grid infill, I changed to gyroid because the walls are so thin, right? This fits on my rigid sander, but not when the spindle is here. You would use this when you're using the belt and it clamps here, and then put your dust collection hose on the back. I've tried it once. It really helps. It really helps. Now, when it comes to spring clamps, these kinds of clamps, because I do want them to still be functional, what I've done is I said for the spring clamp, print with 5 perimeters. 5 layers on the bottom, 5 layers on the top, 25% infill. And that keeps them relatively strong, and I think that'll work. Did almost the same thing with the little C-clamps. 5 perimeters, 5 top layers, 5 bottom layers. I think I did 25% infill with this one. Might have only done 20. I was still kind of experimenting. And again, you know, I'm not going to be using these to glue 2 pieces together and try to take a bow out of one of them. For that, I'm going to break out the big clamps and really make it work that way. The 1, 2, 3 block I printed is actually 2 walls, 2 top, 2 bottom with a 10% infill, which is probably why it's so light. Now, you can change the type of infill and you can go to 100%. You can print this solid. Still wouldn't have the weight, and there's really no need for it. All I'm worried about is setup. So, but that's kind of where that's at. I mean, that's part of it, is your wall loops, your infill top, your infill bottom. Now, one of the other things you can run into is bed adhesion issues, and I think it's important that I address that. I have occasionally taken, you can take it in the slicer. I think it's in support or speed. Speed, right? You have quality in the bamboo slicer. There's quality, and it will ask you what layer height, and mine is 0.2 millimeter, and then it asks what the initial layer height is. And sometimes I'll bump that up to 0.25 instead of just 0.2. Just give it a little more, get a little more squish, as it were. Another thing I do when it comes to speed is I will slow, the initial layer is slower than the main print. Sometimes I will slow that down a little more, and then I'll babysit the printer on that first layer, and I will increase the bed temperature by 3 or 4 degrees just to help it adhere. Because I am going to be printing, especially with like those clamps. You know, I'm printing 5 bottom, 5 top, and 5 perimeters. There's a lot there. So that's something to think about. And you really, that's a good jumping off point. You know, what I've given you is good jumping off points. If it's a generic piece, just 2, 2, and 2. If you're going into something where, you know, it's going to have torsion, it's going to have some force on it, go 5, 5, and 5 with a denser infill. You know, these little things I designed, and then I said print it with 2 layers. But because of that, I got a lot of infill, which is fine. It's not a big deal. I do know people that occasionally will print with 1, 1, and 1, but their infill is like 80%. So it's a very dense object, and the walls are basically there just to keep everything lined up. I wouldn't go any lower than 2, really. You know, and the less wall loops, the less tops, the less dense your infill is, the faster it prints. So hopefully that'll give you a good jumping off point. And the main thing is, don't forget to experiment. That's how you learn. You know, it's the old 10,000 hour thing. How do you get good at something? You do it over and over and over. You repeat. Probably why I'm not too good working with a script. This is the first scripted video I've ever done. I'm hitting the high points. I can't work with a script. I see that now. I need an outline, but it'll work. Anyway, so 3D printing and woodworking, they really do dovetail together well. I hadn't even thought about that. You could probably make a dovetail template to hand cut dovetails. Sorry, Katz Moses. I know you sell one. I know there's other people that sell them, but I bet we could 3D print them. Yeah, I guarantee you we could 3D print them. Anyway, if you're, I've just got to read this. I'm sorry, guys. I had this really great ending and I can't memorize it for friggin' beans. Anyway, whether you're printing custom jigs, shop storage, dust collection, functional light duty tools, the possibilities are endless. If you found this video helpful, please hit the like button on your way out. It really helps get the video out to people. Oh, one thing I did want to know is, if you have a 3D printer, what have you printed? If you are thinking about getting one, what's the first thing you'd be interested in printing? You know, I'm curious. Anyway, I'd love to hear your ideas. Drop them in the comments. Do the doodly do. If you really like what I did and really like what I did, hey, I gotta buy me a coffee link. Give me $1. Hey, big man, let me hold $1. I wonder how many people remember the John Boy and Billy show. Anyway, until next time, I'm Jim from the 312 Workshop. Thanks for watching and have a good day.